right. Greetings, Wireless Village. Thanks for coming to my talk today. So, Brandon has the audio. All right, so today we're going to be talking about how to run a software-defined radio capture the flag using challengectl. So, challengectl is the software that we use to run the RF capture the flag here and some of the challenges. So, what we're going to talk about today is what is the RF CTF. If you've heard my spiel during this weekend, you're probably familiar with this. But just to make sure we're on the same page, we're going to go over what our goals are for the RF CTF, what kinds of challenges that we have, Wi-Fi, RFID, the other RF stuff, other RF. In this case, we kind of use that interchangeably with software-defined radio, mostly because we're using software-defined radio for a lot of it, and that's what we expect people to use to solve it. It's not necessarily the only thing that you could use to solve it, but that's what other RF is referring to. We'll talk a little bit about scoring. We're not going to go super deep into that since the focus of this is on using challengectl. And then we'll talk about what some of those challenges are. We'll dive into challengectl, what the design goals were for that, the current state, and then some future development ideas for it. And hopefully by the end of this, you'll be able to run challengectl. You'll be able to run our software-defined radio challenges at home by yourself on your machine, your software-defined radio, and possibly even write your own challenges or roll the keys yourself. So a couple of acknowledgements real quick. A lot of people have contributed to make the RF CTF happen. That's for all the different challenges. So I'm going to be talking about one aspect of it, but to actually make the event that you're seeing in front of you, it takes a lot of people. Current and former RFHS staff, there are a lot of people that have contributed and volunteered over the years. Friends of the village, we have folks that haven't technically been on staff, but are good friends of the village and have contributed a lot in terms of challenges, technical support, releasing great products, releasing great libraries, other software that we make use of. And then specifically for challengectl and the software-defined radio challenges, I want to give acknowledgments to Russ Handorf. He is the person that introduced the software-defined radio aspect to the RF capture the flag. And then Corey Koval also, he was the one that originally wrote challengectl. I've been making some contributions, but Corey is the one that wrote the original wrapper for all of these challenges. So what is the RF CTF? So it's a radio frequency capture the flag, and the goal is to capture, identify, and decode or interact with lots of different RF signals. And these can range anything from Wi-Fi to Bluetooth, RFID, amateur radio, other types of RF, things like tire pressure sensors, industrial control systems, basically anything that communicates wirelessly, we're interested, and that can be a part of our challenge or a part of our contest. And our goals are a couple of fold. So one, it's a competition. So it is a contest, and we want to see who can solve the most challenges, who can solve them most quickly, all that kind of stuff. But the main goals are learning and experimentation. We want this to be an educational activity. We want people to be able to come and try out their tools, their software, be able to attack our networks and signals, and really play with stuff in a way that they wouldn't necessarily be able to at home or out in public. So things like, we've got restaurant pagers. If you want to try to set some of those off, set ours off and don't tick off the local restaurant. Try out new different attacks and things. Try out aspects of amateur radio or just wireless experimentation that you've not gotten a chance to do at home. So real quick on scoring, one of the things that makes it a CTF contest or a capture the flag contest is the scoring. So again, we're not going to dive super deep into this, but I want to acknowledge that this is a really important part if you're trying to make it a game. You have to keep score some way. If you want to just set this up for learning and experimentation, you can run all these challenges and just have a good time, not worry about scoring at all. Typically speaking, each challenge will have a certain number of points assigned to it. There are some other things where it's you'll accumulate points based on how long you were in control of an access point or something along those lines. Those are a little bit different, but most of the challenges are, if you solve this challenge, you submit this flag and you get this number of points. If you're going to be running a moderately sized capture the flag or larger, so something like this, you need some sort of scoring system. I mean, you could use paper, just write down scores for people if you have a small event, just a handful of people, or if you're doing this with a couple of coworkers or something. But for something like this, you need some sort of automated scoring system for people to put points in, or put flags into, have them validated, and then assign points. Right now, we're using CTFD. That's an open source project that you can download and run yourself. You can also, I think you can pay them to host it. We're hosting our own. And we've tried with a number of different roll your own scoring systems in the past. So over there on the right side, you can see that's our previous scoreboard, and down below that is CTFD. That's what we're currently using. All right, so I mentioned typically the scoring is you get a certain number of points per challenge. So at a basic level, what is an RF CTF challenge? So this is a discrete wireless signal or a device to decode or interact with. So we want to break down the capture the flag into little small nuggets, discrete things for people to do. So capture this Morse code signal, or set that pager off, or decode this other thing. Things like Meshtastic is really popular right now, but Meshtastic is not a capture the flag challenge. We could have a Meshtastic challenge, but it would be we're sending out a message. Decode that message, find that message, or send me a message on Meshtastic. Find this node, find this device, something like that. We have to make it a little bit more specific and something that people can actually digest and solve. A couple of requirements, things that are required for our capture the flag challenges. Number one, it has to be legal. It has to be legal for both us to transmit and for the contestants to receive. So this is one of the reasons that you won't see us running a cellular challenge, for example. We don't have the licenses to be able to transmit on cellular bands. Contestants don't have licenses to be able to monitor that. That would cause all sorts of legal problems. Even if we were able to run our own cell tower, for example, it would be problematic to get the contestants to decode that. We would also potentially be encouraging people to do something that could get them into legal trouble if they make a misconfiguration or something. So we've tried to avoid things like that. Similar sort of thing with things like ADSB. There's potentially ways that we could run an ADSB challenge, but we need to modify that in a certain way so that people aren't sending out packets and disrupting local air traffic, that kind of stuff. Another requirement is the challenge has to be solvable. Now, what this means, it doesn't necessarily have to be solvable with some off-the-shelf software. There doesn't have to be an easy solution, but there has to be an answer for people to get to. So it can't just be, we're transmitting something, good luck, let us know what you find. That would be hard to score, also frustrating for the contestants. You don't really know when you get to the end. And we want there to be a defined end to each of the challenges. The challenges also need to be repeatable. We have to do this every single time, the same way every single time. And so throughout the course of the weekend, we're transmitting challenges hundreds of times, if not thousands, and it needs to be the same every single time. And we need to be able to do that at least for the course of the weekend. It's even better if we can have rollable keys, so easily changeable keys, where we can change that between conferences. But if nothing else, it has to be repeatable for the duration of the contest. A couple of nice-to-have things. We'd like for the challenges to be solvable with commodity hardware, things like an RTL SDR or a Blade RF, a Hack RF, things that people would commonly have and might be bringing to conferences. We try to avoid things that require specialized hardware. So if you need, let's say, one example that we've run a couple of times is 60 gigahertz Wi-Fi. There's specific hardware out there that you need for 60 gigahertz Wi-Fi or frequencies in that range, and that's not something that people typically carry around. When we've done that, we typically have gear available to loan to people to do that, but that is a little bit inconvenient on our side to be able to, just bringing more gear. It's another thing to bring, so nice to have is making sure that we can transmit it and that contestants can receive it with commodity hardware. And then another nice to have, I mentioned that the challenge has to be solvable. It's nice to have things like Multimon that is meant for decoding pager traffic, or other software for FL Digi for decoding some of the amateur radio modes. Those are nice to haves, but even if you have to go to something like InSpectrum or URH to manually decode some of these signals, that's okay. Sometimes that is meant to be a hard challenge, but it's nice when there's something out there already for folks to go and use. This way they can go and experiment with the protocols. It makes the challenges a little bit more approachable than there's a signal out there with no software that we know of to decode it, good luck. So those are some of the requirements and nice to haves. So there are a few rabbit holes that go into making the RF capture the flag that are outside of the scope of this presentation. So for the Wi-Fi challenges, check out the RF CTF container and some of the other repositories up on the RFHS GitHub. For the Foxes, Kitsune is that's the software that we run on the little Fox modules. And just for reference, the Foxes, we're talking about the Fox and Hound type challenges. So that's where we give a person a wireless transmitter. They go around the conference just enjoying themselves like normal, and then the contestants have to go find that person based only on the information about the wireless transmitter. So the code that we're using right now for that is Kitsune. That's up on our GitHub as well. For RFID challenges, those are not transmitted with challengectl. So we have a building in a box that RTA created for us, and then you can also look into RFID door simulators for creating RFID challenges. Those RFID it's more realistic when you have real readers, and so when you have a real reader configured to read the credentials that you're trying to get people to attack, that ends up being a more engaging RFID challenge. But those are outside the scope of this presentation. Just want to make you aware that is also part of the RF capture the flag and things that you could look into if you're looking to run this kind of event yourself. So running RF CTF challenges and running specifically the other RF, so not Wi-Fi, not Bluetooth, RFID, that kind of stuff. One of the ways that you can run these is using dedicated hardware. And you'll see examples of this up there, things like pagers, TPMS sensors, the RGB light wands that we have. We used to have a DVB-T transmitter. There's a couple of examples up in that picture. There are 6 low-pan radios, 802.15.4, a couple of different pagers and whatnot. So the pros of this is that when you use off-the-shelf hardware doing exactly what it was designed to do, it's very reliable. It's also very realistic. So those are great, and it's always fun to have stuff where people have seen these things and go like, hey, I've seen that before. I know exactly what that is. I've seen that in my local restaurant, or I've seen that in a hospital, or isn't that a pager from the 80s? And the answer is yes. Like, those are all real devices just doing their thing. Cons of this are scalability. The more of these types of things that we add, the more hardware we have to bring. So that just adds weight, adds complication in terms of getting the equipment to events. It adds expense because we have to go buy these things. We may or may not do that anyway for challenge development, but that it just reduces the scalability a bit. Replacement is also an important concern. If you have dedicated hardware, like if that pager fails, that challenge is no longer in the CTF. And I can't just run out to the store and buy like a tire pressure sensor necessarily. I mean, we probably could. That's probably the most easily replaceable item on that page. Some of the pagers and some of the dedicated hardware, though, you can't just run out locally and get if you need to replace it. Another con for some of the off-the-shelf stuff is the ease of changing keys. So that pager, for example, that's got number 61 on it. That pager is always number 61. And there may be a way to change it with some other dedicated hardware, but it is not easy to change. That pager will always be that number assigned to that system unless it gets reprogrammed some other way. Same thing with that tire pressure sensor. It's got its own ID. It'll always be the same no matter what, basically until that battery dies and can't be changed. So those are some of the cons. It is nice, again, because they're realistic, they're engaging, and they're very reliable. So the next step up from using dedicated hardware is using individual SDR flow graphs, things like GNU Radio or other types of scripts and whatnot, to be able to transmit using a HackRF, Blade RF, USRP, any of these types of things. These are great because they're easier to prototype. It's easier to roll the keys, usually, assuming you've designed that in a way where you can roll the keys and actually change things. And you can transmit it with commodity hardware. Downside to this is how most of our challenges start, is by an individual flow graph. I have one radio, I'm doing one thing at a time, I tried it out, great, it works, that's good enough to be a challenge. The downside is when you do the development like this, you're tying up a single SDR device to one challenge or script, and so that device will just be doing that one thing. And then starting and stopping those things with multiple devices, you are basically limited. Like, if you turn off the GUI and make this into a script that just runs once and exits, you can wrap that in a bash script or something like that, but you're still essentially limited to the same loop, just one device running that one script. Let's see, subdividing individual SDR flow graphs or scripts. So when you're creating these individual scripts, there's essentially 3 different things that you can do with them. So you can do a capture and replay. So I mentioned like the dedicated off-the-shelf hardware. One of the things that we could do with that is capture the raw IQ and just replay that IQ file, just a raw capture, which is fine. Like that will work. That'll be functional. It's kind of messy, a little bit noisy. If we don't do some additional filtering and stuff, then you could be capturing other noise. It's not really the best way of doing things, but it would work. Next way, generating binary or audio files to transmit. This is how some of our challenges are done right now, where you generate a binary file and then use that into a more generic script to transmit that out of your SDR. So that's reliable, but rolling keys can be challenging. So right now, with the challenges that we have running out of the SDR box, it takes roughly 2 hours to roll the keys. Not because like there's that many challenges that there's just so many things to do. It's that the time that it takes, the FL Digi is what we're using to generate some of those keys, and it's doing everything in real time. It's meant for interactive use, and so it is replaying everything in real time or encoding things in real time. So we have to wait for everything to finish generating and then save off the WAV file, and then do it again to test to make sure that worked. And then there's also complication in terms of making sure that all the files are the right format and all that before they go into the flow graph. So then the ideal state is when you're generating the signals entirely within the flow graph. So you give it the key that you want. So if I want the flag to be the quick fox, jumps over the lazy dog or whatever, I just put that in and it generates everything for me. I don't have to wait for it to generate a binary file or anything, and it just goes. So next thing to consider for scaling up from those individual scripts is scaling up with multiple devices. So the main advantage that you get with this is that you will be able to get more challenges in the air with standardized hardware. So you can absolutely run all of these challenges on a single device. The downside is that you're limited to that one device. That device can transmit usually one thing at a time, so you have one challenge in the air at any one time. And if your contestants are waiting for a specific challenge to come around, then they have to wait for all the other challenges that you have going to be transmitted before it gets back to the one that they're interested in. So if you add multiple devices, then you can have three or more, however many radios you can have that many challenges in the air at the same time. This is something that we've prototyped over multiple years, going back to roughly 2014. Russ Handorf, who I mentioned earlier, his original SDR football was actually using a couple of Raspberry Pis and Pi FM to transmit some of the challenges. That was quick. We relatively quickly moved on from that to using a couple of hack RFs. And so the diagram up in the top right is essentially a functional diagram of the original Software Defined Radio football. There were a couple of Raspberry Pis controlling a few hack RFs, and then those going out to a couple of amplifiers. There was also a DVB-T dongle. That's that specialized hardware. Some of that specialized hardware I mentioned before. And from what I remember about running challenges on this, there was essentially one script per device per hack RF, and then there was synchronization happening through a database that was on one of those two Pis. So that was essentially the first iteration of Challenge CTL before it was called Challenge CTL, but that was how we were coordinating some of the challenges and having each of those hosts go through and check, is there a challenge available? Is there one that I need to be running right now? And do I have, am I ready to transmit that on this device? Fast forward about a decade, and now we have our current generation SDR box, which is the picture in the bottom right. That is using 3 Blade RF 2.0s, and that is running Challenge CTL, which is a single Python wrapper to do all that marshalling and scheduling. So like I said, this is the current generation of our SDR box. It's running in Python. It's a multi-threaded Python application to manage the CTFs, or CTF challenges. It manages a list of software-defined radio devices, so it knows that it's got, in this particular case, it has 3 blade RFs. It checks to make sure that device is available before it starts transmitting, and then when it finds an available device, it will check to see if there's a challenge that it needs to be transmitting, and will take that challenge and start sending it. It manages a list of challenges, so we're not limited to 3 challenges with this. We have probably 15 or 16 different flags being sent out from these 3 devices. And it'll cycle those challenges across devices as they're available. This is also doing some spectrum painting. So if you've seen our display over that direction, where we have the various different sponsor logos coming across the spectrum, that display isn't mixing them into the spectrum. That's doing that after the fact. But for Challenge CTL, we are actually putting our logo out on the radio frequency right before we transmit the challenge to make sure that contestants are aware that one of our challenges is coming. So right now, there are a handful of different types of challenges in Challenge CTL. First type is Morse code. Next type is amplitude shift keying. Then we have narrowband FM and upper sideband flow graphs for transmitting some of the amateur radio digital modes. All 3 of those are actually carries over from the original SDR football and what Russ Handorf developed, I think, in collaboration with Argilo and some of his SDR examples. But those are some of the challenges that we've got. We've also got POCSAG and the Long Range Systems Restaurant Pager Challenge being transmitted out of that box as well. All right, so demo time. So all of this is open source. Challenge CTL is open source software. It is available on our GitHub. And so if you go to github.com/RFHS/challengectl, there's a link to this from our website as well, rfhackers.com. But this is the project that you're going to want to be looking at. So this is what we use to transmit out all those challenges. We also have this flags archive where we upload challenges from previous CTFs. So what I'm going to walk you through right now is actually running all of our challenges as we were running them at ShmooCon. So on my laptop here, I have just a single blade RF, so not as fancy as the SDR box that we have up there with 3 of them. But so if you git clone the Challenge CTL, you'll come out here. You'll have a number of different scripts here. First one to take note of is the create devices.text.py. So one of the things that Challenge CTL needs is it needs 2 things. It needs a devices file and a flags file. So first thing we need to do is generate that device file, and then I'll show you the flags files as well. So there are also a number of other examples up here. So the flags.text.ci, that's for testing to make sure that we don't have any new errors, just for essentially continuous integration, continuous testing. But to create those, and we have some examples for. So this is the general format of the devices.txt file. So it's going to have a device ID or a device index, and then the device string for Osmo SDR. The nice thing is that this script that I'm about to run will generate that file for you, so you don't have to remember any of this, you don't have to worry about it. So what that script is going to do is that'll query your system for any SDR devices that you have, and it will put those into the devices.txt. So that's the devices.txt file for my laptop right now with just this one SDR. Next thing that we have is the flags file. So I mentioned that we have a lot of our previous conferences uploaded here with all the challenges that we're running. So for ShmooCon 2025, so this is a conference that we ran the CTF at in January. And this is what the flags file looks like. So essentially what you have here is first line is the conference name and the start and end times, and then everything after that is an individual challenge. And you'll see from here we've got the ham digital challenges. So these are all the amateur radio digital modes. Those are things like RTTY or Thor or Feldhell. There's a couple of different other ones. Basically anything that can be encoded into an audio file can go into that type of challenge. So you have a challenge name. For those files, the wave file is one of the arguments for it. You'll see one of the things that we need to work on is getting a more consistent format for some of these things. This field has a wave file for the upper sideband, narrowband FM, and narrowband FM flow graphs. And then there are some other parameters after that for the audio sample rate and the frequency that you're transmitting on. We also have the capability to transmit on different frequencies or randomized frequencies. So when you see things like ham 440, that is anything in the amateur radio band at 440 megahertz could be transmitted anywhere within that range. So this challenge is a little bit more difficult because it's not on the same frequency every time. Moving along from there, the Morse code challenges. These are one of the ideal state challenges where all you have to do is put in the text that you want sent in Morse code and make sure that the frequency is right. There's also some parameters for changing the speed of the Morse code, but you type in the key that you want and that's what will be sent out over Morse code. No generating wave files or bin files or anything like that. The amplitude shift keying challenges are basically the same as the CW ones. Those are type in the challenge, type in the flag, and that'll be sent. POCSAG is a little bit different in that there's an extra parameter for the cap code in addition to the flag. And then LRS is a little bit different in that these parameters are passed directly to the script that is generating a bin file. So this is kind of an intermediate between generating a bin file or a wave file before running all of this. This script will generate the bin file on the fly and then transmit it out. And that's ephemeral. So that's could be a little bit better, but it is that is how that is working. And then the SSTV is a similar sort of thing to the other digital modes in that we have a wave file that we generate, in that case with QSSTV or any other SSTV programs, and you plug it in there. Also in the flags archive, we have all the wave files. So these are all the wave files that were in that flags file. So this is exactly what we ran at shmooCon. So once you have all that, all you have to do is run challengectl.py with the flag file. And your device file. And so once you run that, assuming you have all the files in the right place and all that, it'll pick up your SDR device that you defined earlier. And right now, this is spectrum painting on that frequency and transmitting out the challenge that we had running at shmooCon on 905.55 megahertz. We'll stop this in a second. I don't have an RTL to show you actually decoding that over the air, and this is probably interfering with some of the contestants at the moment. But that is all you have to do to run our challenge at home. So again, this is if you're running this with just one SDR, it's only going to be transmitting one challenge at a time. If it's just you doing this for practice for fun, that's probably enough. But you can scale up from there and run with multiple different devices if you want. Let's see, one of the other things that we can look at is, I mentioned FL Digi. So that is, if you want to roll some of the flags for the digital modes, FL Digi is what we're using to generate those files. If you open up FL Digi, there's an option. So this is meant for, it's essentially amateur radio, either contesting or just using digital mode software. So this would normally be used interactively with other hams across the world with an HF rig and all that kind of stuff. There is also an ability to generate these wave files. So if you want to, let's say we wanted to generate a RIDI flag for right now. So if we picked RIDI 45 and then said ham digital 9, this is a test flag. You could go up here and in the audio menu, TX generate, generate a wave file, hit transmit, and it'll go through and actually put that into a WAV file that you can then use in challengectl. Now, if you do that, make sure you double check the sample rate of the audio file and the sample rate that you have set in the flow graph, because that is something that just bit us a few minutes ago. 8,000 hertz, as it turns out, is not the same as 48,000 hertz, but it's easy to miss. But yeah, that's what you need to do for generating new flags for any of the modes that FLDigi supports. If you want to check to make sure that that worked, you can also go back up there and stop the TX generate and do a playback, and then load that WAV file that you just created. You play it on a continuous loop, that'll just start going, and once you see it decoding on that same mode that you just did, this is what the contestants should be seeing after they get it either over the air or over the virtual syncs for the virtual side of the game. Then QSSTVs, some other software. So that for the SSTV challenge, this will also generate WAV files for you. If you transmit and have your options set to sound for sound output, sound card, and record, that'll generate that WAV file that you need to put into challengectl for the SSTV challenges. From there, you need to load up an image of some kind, and then it'll generate the flow graph for you, or it'll generate the WAV file for you. All right, so that is essentially challengectl. That's what we're using for all the software defined radio challenges. And so in that short amount of time, we just ran the ShmooCon 2025 RF CTF from this laptop right here. You can also do that at home. A couple of ideas for future development. So I mentioned the virtual challenges. We also have a virtual side of the game where we are sending those same files, those same WAV files, over a zero message queue sync, essentially so you can stream it over the internet. It was prompted in DEF CON 2020 during COVID. That's what really prompted to set a fire under the development idea, since we couldn't come out here and actually run the CTF. But right now, challengectl does not run those. It shouldn't be too hard, trademark, to integrate those into challengectl, but one of the considerations there is that the parameters that you need for running a virtual challenge are different from the ones you need for a physical challenge. So for a virtual challenge, there's no frequency. There is a port. Some of the things don't really matter. The bandwidth might be different. There are just some aspects of it that don't matter for the virtual side that do matter for the physical side, and vice versa. So getting that all into one consistent format so that you can have one flag file or one flag file format to be able to do all that, that would be a nice to have. That's something that we'd like to do, so we have just one software stack running all of the challenges, both physical and virtual. Another nice to have that we'd like to work on is having multiple coordinated SDR boxes. So right now I've got two different boxes up there. One has two SDRs in it, one has 3. They don't communicate back and forth with each other about what's running. So the way we're dividing that up right now is one box has all the main challenges that are running both virtually and physically. The second box has things that are special, running just in the room or haven't been integrated into challengectl yet. But it would be really awesome to be able to have multiple SDR boxes that communicate over a network and say, like, hey, I'm running this challenge, I just transmitted that one, all those sorts of things, so we can have even more challenges on the air without colliding with each other. Another nice to have would be adding logic for multiple transmit front ends. So the Blade RFs have 2 different transmit ports, and it would be really neat to be able to have different antennas on there for different frequencies or different filters, all that sort of thing. We have the start of that logic in there, mostly because one of the ports on a Blade RF that we have broke in transit. So it literally snapped off the board, and we need to transmit out the second port now because the first one is broken. So that specific device is hard-coded in there to always transmit out the second port. We need to polish that up a little bit and actually make that a little bit better. Another thing that we need to work on is having sensible gain defaults based on your SDR type. So the Hack RF, Blade RF, USRP, the gain settings for all those are all different. We need to make sure that we have a consistent gain settings, at least across all the challenges for all the blades, but having sensible gain for hack RF. So if I know I'm transmitting from a hack RF, saying I know this is a reasonable setting for that, and setting that automatically would be really nice. I'd also like to make use of the Blade RF gain calibration. So if you have a Blade RF 2.0, Nuon is actually calibrating them for doing a gain calibration. So there is a curve for your transmit frequency and how much power you're actually transmitting. You can standardize that to have it be a flat, consistent gain across the entire spectrum. I think it'd be really cool to have that integrated into Challenge CTL as well. I showed you the FL Digi and how we're rolling the digital mode keys, and that's a little bit painful. One at a time is not that bad, but if you're doing 6 or 7 of those, it takes a little while. If there's a better way, I'd love to do that. As far as I know, or at least we haven't found yet a way to programmatically have FL Digi generate those files and not have to sit there and wait for it. If there's a better way, I'd love to hear about it. If any of you know about a better way to do that, I'd love to hear it. But that's another nice to have future development goal. I mentioned we could do a transmit and capture and replay type of challenge. We don't currently have a flow graph for that. It won't be that hard. That's a relatively simple thing. We just don't have it in there yet. But that'll let us integrate some of the like some of the Woody's crazy challenges where there's one device that does this thing. We could integrate that and have that transmit a little bit more regularly. And then something that we're perpetually looking for are additional challenges, additional things that we can integrate into Challenge CTL. Even if it's not quite ready to go into there, we're always interested in adding more stuff. One of our goals is to have as many different types of signals out here as we can, just to give everybody something interesting to look at. Not everybody's interested in Morse or the digital modes. Some people are more interested in certain challenges versus others, and we like having all the things so you can choose your own adventure. And that's all I got. That is Challenge CTL and how to run your own RF CTF at home. So, any questions or comments, concerns? Lasagna. Yeah. I think so. The question is about containerizing the SDR challenges and Challenge CTL. So you're asking if we can containerize Challenge CTL and how to run those challenges? Yeah. That is true. That's correct. The virtual SDR challenges have not been open sourced yet. One of our goals is to do that, and basically, when those are open sourced, they will be in Challenge CTL. So, the flow graph is essentially the same. It's instead of a Blade RF or a Hack RF or an Osmo Comp sync, we're using a ZMQ sync. And then the examples that we have, the RF CTF files or whatever it is, also on our GitHub, those flow graphs are just the ZMQ source into a file or into an audio sync or something like that. And those are examples just to get folks started. But yeah, that is essentially what's happening on the other side. We have a different, so we have our own challenge runner that's running on the virtual side, specifically designed for the virtual things. And so there shouldn't be as much of a difference between the two. They're already very similar. And so the first step for Challenge CTL is likely going to be running Challenge CTL in either a physical or virtual mode. And then we can have all the virtual challenges just with a different flag format or something like that. And so, but this way we'd at least have one program and one set of flow graphs, or two sets of flow graphs essentially for those challenges. So that is not out there yet, but it will be. Not sure. Probably when we're good and ready, but That is not a hard and firm answer. That is just like the place where they're at right now has the other secret sauce for the for the CTF. So yeah. Got any questions? Looks like no. Hey guys, thanks everybody for coming to my talk and sticking through the end. And if you have any more questions or want to play in the CTF, come see me at the CTF table. Thanks.